Hello, Problem Stats students. We're going to use this review worksheet here to help you get ready for your quiz that's coming up this week on sections 3.1 to 3.3. And so I'm going to go through this review worksheet to help you kind of check your own work and see if you're doing this correctly. And I'm just going to fill in the answers in these text boxes, these tan text boxes, as I talk out loud and think through them. So here we go. Question 1, determine if each of the following is a valid statistical question. Justify your answer. So here's the first one. How many votes did Kim Reynolds receive in the last governor's election? Well, how many she got in the last election would not be a statistical question. And the reason for that is there's only one answer. She got, I don't know how many votes she got, but I'm sure we could look it up on Google and it would say she got this many thousands of votes. And that's just the exact answer, and it doesn't change. So the key thing here is thinking about, does the answer to that question ever change? And here it does not. She got the number of votes she got. Question B is asking you, what percent of Iowa residents approve of the job the governor is doing? This definitely is a statistical question. And the reason for that is because the answer will change depending on maybe when the question is asked. As she goes on and makes different decisions about our state, some people's opinions might change as she makes different policy decisions. It could depend on not only when the question is asked, but what people are asked. If she walked into a Republican voters convention, she's probably going to have a lot of people that support her and approve of the job she's doing. If she walked into a Democrat convention, then she's probably going to get a different answer, and fewer people are probably going to support her. So that one is statistical because it's going to change. Question 2, it says an online retail store mails a customer satisfaction survey to people who make credit card purchases at the store. This month, 45,000 people made credit card purchases. Surveys are mailed out to 1,000 of these people who are chosen at random, and 137 people return the survey form. Identify the population and the sample in the setting. Before we identify the population and the sample, I just want to point out, since this form was mailed out to people and people chose to respond to it, whether do I want to mail that back to them or not, this is a type of sample called a voluntary response sample, because those 137 people chose to respond. Now, who is the population in this problem? And who is the sample? Well, the sample would be the people that responded. So it's the 137 people that responded. Who is the population? You got to think, who did those people come from? Those 137 people were basically coming out of the group of 45,000 people that made the purchases. So the population is the 45,000 people that made purchases at the store. And out of those 45,000, yes, they identified 1,000 of them, but the sample is not the 1,000 because 1,000 people didn't actually give any information or respond. It was only those 137. Question 3, does the lack of sleep affect your academic performance? Good question. A teacher explores this question by asking everyone in his statistics class to write down on a piece of paper the total number of hours he or she slept on each of the last 3 nights before taking a test. He divides the student into those who slept for an average of 8 hours or more each night and those who slept for less than the 8 hours. And then he compares the average test scores of the two groups. So if I was to do that, I would want to see what's the average test score of the students that got the 8 hours of sleep or more, and I'm going to compare that to the students that didn't get as much sleep. Is this an observational study or an experiment? This is definitely an observational study. Notice the teacher didn't tell the students how much to sleep. He didn't force the students to sleep a certain amount of time. He just kept track of who slept certain numbers of hours and then how they did on the test. So it's an observational study because nothing was done to the students. He, the teacher, just observed how many hours of sleep each student got and how they did on the test. So that's an observational study. Question number 4, it says aspirin prevents blood from clotting, and so it's used to help prevent strokes. The European Stroke Prevention Study asked if adding another anti-clotting drug named, oh boy, I got to try and say this, dipyridamole would help. So that's another drug that they're going to be looking at. And it says patients who already had a stroke were randomly assigned to receive either aspirin only, dipyridamole only, or they would get both drugs, the aspirin and the dipyridamole, or they'd get a placebo, the fake drug. And then researchers examined how many people in each group had strokes. Is this an observational study or an experiment? Explain your reasoning. This is definitely an experiment, and the reason is because the patients were assigned to different treatments. Some got aspirin, some got the new drug. I'm not going to try to retype it. Some got both drugs, and some got a placebo. But you can see that something's actually being done to each of these people. Okay, we're not just sitting back and watching and saying, who has a stroke or not. We're giving certain people each of these different drugs or combinations of them or the placebo. So because we're doing something to them, it is an experiment. Question 5. It says the band director at a high school wants to know what percentage of parents support a decrease in the budget for fine arts. Because many parents attend the school's annual musical, the director surveys the first 30 parents who arrive at the show. And we are wondering what percentage of people, of these parents, support decreasing the budget for fine arts. So they want to spend less money on the fine arts programs. Okay, so what type of sample did the band director obtain? So remember what's going on. He's sitting there at the door as the school's annual musical is going to begin in a while, and it says he surveys the first 30 parents who arrive at the show. So this is what we would call a convenience sample, and it's convenience sample because he's just sitting there and doing what's easiest for him. These people are walking by. He just happens to ask them, do you support decreasing the budget for fine arts? Notice he's not randomly getting a sample. People are not volunteering. He is asking the people that just walk by him, but because they're just walking by him, that's making it very convenient and easy for him. So it's a convenient sample. It is easy for him to just survey the people as they walk by. Why is this sampling method biased? Okay, well, you got to think about what's going on here. So we're trying to figure out what percentage of parents, I'm going to highlight the question again, what percentage of parents support a decrease in the budget for fine arts? And notice who he is asking. He is asking parents who are going to the school's annual music show. Well, think about these people. If these parents are going to the annual music show, likely they have a student, a son or a daughter or somebody who's performing in that show. And so very likely the people that are coming to this show are supportive of the fine arts. They support the music program, the band program, the choir, and things like that. So you're asking people who probably most likely already support the fine arts. So it's biased because, watch my typing skills here, it's biased because the director is asking people that are attending the school musical and probably support the fine arts program because of that. Okay, if they're attending the musical, they probably like supporting the fine arts. So the question then goes on, it says, is the proportion of parents in the sample, remember the 30 people that he talked to, who support the decrease, is that likely greater than or less than the proportion of all parents in the school who support the decrease? Well, again, you're talking to people that are attending the musical program. So they probably support the program, and therefore they probably do not want to decrease the funding. So I would argue that the proportion of parents in the sample who support decreasing the fine arts funding is probably less than the proportion of all parents. You know, there's a lot of parents that don't have kids in the band program or in the choir and in arts and things like that, and they might feel like, yeah, let's cut the funding for it, let's put it somewhere else. But when you're talking to band parents and choir parents, probably not many of them are going to want to support decreasing the funding. So it's less than the proportion of all parents because the people in the sample are parents of band, choir, art students, and likely will support that program and not want to decrease the funding. Okay, how could you avoid bias in this problem? Well, if we're biased with it, the problem with bias is how we selected the sample. And the problem is that the director did not randomly sample all parents. So the director should get a random sample of all parents at the school, not just talk to music parents. Okay, and we know how we could do that. We've talked about how to create a simple random sample. You could number all of the parents from 1 to however many there actually are. Say there's 1,000 parents, and you could use the Google random number generator to create, maybe you want 30, I think he had 30 before, 30 random parents to talk to. Okay, question number 6. Many people call the customer service helpline at U.S. Bank to get help with their accounts. Since so many people call, they are often put on hold and they have to wait, and U.S. Bank wants to estimate what is the mean time, the average time that callers are put on hold. And to do this, it says they get a simple random sample of 100 callers and find the average wait time for them was 12.5 minutes. So the first question, describe how U.S. Bank could get this random sample of 100 customers. Okay, well, we were just talking about this for the band and music parents question above. So what we could do to get the random sample is we could give all customers an ID number, and we would go from 1 up to whatever the highest number of customers is. You know, say I knew that U.S. Bank has 5,000 customers, then we would do from 1 to 5,000. Okay, so example 1 up to 5,000. Then what we would do, we would use the random number generator to create, how many do we want? 100 random numbers. The key thing to it though, got typed correctly. They all need to be different. I don't want to have customer number 4,312 and then another customer 4,312. And then these 100 numbers represent the 100 customers we would use in our sample to ask them how long they waited. Okay, question 2. Do you think the mean time that all callers were on hold is 12.5 minutes? Okay, remember the 12.5 minutes came from the random sample of 100 customers. And we're wondering, is the 12.5 minutes average time for the 100 customers, would that be the same as the average time for all of their customers, say all 5,000? And the answer to that is almost definitely not the same as the mean time for all customers. Think about why. I put a plot down here. This is the plot we used for the Gettysburg Address. When you guys were taking samples of 5 words, remember the truth was this blue line, 4.26. None of us got 4.26. Many of us got lower than that. Many of us got higher than that, but almost nobody got the exact true number. And we have to remember that that's happening because when you take a sample, it's almost definitely not going to be the same result as of the entire population. And the final question says, suppose the customer service manager only had time to collect a simple random sample of 25 collars before reporting back to the boss. Remember, before their sample was 100. What effect would this have on the estimated mean time? Okay, this gets back to the idea of sampling variability. If you increase the sample size, then you are going to decrease the sampling variability. Well, in this case, we're going backwards. We had 100 people in the sample. Now we're going down to only 25. So if we decrease the sample size here, then what's going to happen is we will increase the sampling variability. What does that mean? That means if I take a smaller sample, my sample average will likely be further away from the true mean. Okay, so back up here, when we took samples of 5 words, if I said, oh, we don't have time to do 5 words, let's just do samples of only 2 words, what we almost definitely would have seen is that we would have had a lot of dots and results that were further out here in the 6, 7, 8 range and further down here in the 3, 2, 1 range. Because if you only get 2 words, chances are you might get 2 small words or you might get 2 bigger words. Okay, so what's going to happen is the effect would be that your average will likely be further away from the true mean because you took a smaller sample. All right, hope this helps you for your quiz. Remember, always let us know if you got any questions, and we are happy to help you.